Higher maths, trigonometric expressions. Today we are looking at trigonometric identities. So over recent lessons we have looked at sine of a plus or minus b, the cosine of a plus or minus b. So we've been using that quite a bit. And we've just looked at double angles. So we've just done those. At National 5, so these are given in the exam on your formula sheet, guys. You don't need to remember them, you just need to be able to use them. Here, sine squared a plus cos squared a equals 1. That is your National 5 trig identity. And tan a equals sine a over cosine of a. That is your second National 5 trigonometric identity. Okay, so we need to, well, you will be using these lots, so you will probably remember them anyway. You don't need to write them down or anything at the moment, but they do come up in the exam quite often. You just need to be able to apply them. But again, you will be doing a lot of it in class, so you will just remember them over time. Sine of 90 minus a, we can show that that is equal to the cosine of a just by replacing the a and the b with 90 and a here, and just working our way through as we're about to do in the first example. So example 1, prove that the cosine of 270 plus a degrees equals the sine of a. Well, what can I do with this? So when doing a trigonometric identity question, it is quite often a case of what can I do, not what do I do. Because each one is often quite unique. Obviously, the more you do, the better you get at it, like all sorts of maths. But sometimes you can't see where to go, you can't see how to get from the start to the finish, so you need to take a leap of faith. So prove that the cosine of 270 plus a equals the sine of a. Now, as it says up here, we've got to start with the left-hand side and end up with the right-hand side. So cos of 270 plus a, now what can I do? This is basically my trigonometric knowledge. I've got cos of something plus something. So what I'm going to choose to do is just to expand this using cosine of a plus b. I don't think there's anything else we could do with that. That's the only thing we could do. What we definitely cannot do is write cos 270 plus cos a, because that would be absolute nonsense. It doesn't work that way. Please do not do that. Please do not do that. So cos of a plus b, so cos 270 cos a minus 2 sine 270 sine a. Now what was the cosine of 270 degrees? To find that, I would quickly sketch my cosine curve and find out at 270 that the height of the curve is 0, so the cosine of 270 is 0. So 0 multiplied by the cosine of a is just 0, minus sine 270 multiplied by the sine of a. Well, the sine of 270, sketch the graph again, guys. The sine of 270 is negative 1. So I have 0 minus negative 1 multiplied by sine a. Well, those two signs will make a positive, so we'll have positive 1 sine a, or we just have sine a, which is what we've been asked to prove. So what did we do? Structure-wise, very important. We started with the left-hand side. Did I write on this line that that is equal to the sine of a? Absolutely not. Please do not do that. We expanded using the cosine of a minus b. Sorry, the cosine of a plus b. I then evaluated anything I could. So cos 270, used the graph. Took me 7 seconds to draw that graph, guys. Sine of 270, again, it took me 7 seconds to draw that graph again. So that is 0, that is negative 1. So I end up with 0 minus negative 1 sine a, which is just sine a. Again, structure-wise, start with the left-hand side, end up with the right-hand side. Very, very important that you do it that way.